Alright, so we're going to talk about adding and subtracting radicals right now. So it may seem intimidating at first when you see something that looks a little bit like this, but it's really not that bad. What we need to remember is that when you're adding or subtracting radicals, uh, you can only add or subtract like terms. So just like if I had 7x plus 2x, I could easily add those together. Well, 7x's plus 2 more x's gave me 9x's. Okay? So just like this, if I have 7 root 3's and I add 2 more root 3's, well, that really just gives me 9 root 3's. All you need to worry about really are the coefficients here. These radicands are the same, so these are like terms. I can just add them together and just add my coefficients. Okay? Of course, they're not always going to be that simple. Okay? What if I don't have like coefficients? Well, just imagine the second example. If I had 4 root 3 plus 2 root 5 minus 3 root 3, well, these root 3 terms would be considered like terms. The root 5 term is completely different, so I can't add that one with the others. But if I look at the root 3 terms, I've got 4 root 3's, subtract 3 root 3's. Well, that really gives me 1 root 3, right? Or I could just write that as root 3. I don't need to write this 1 out in front, because if it's not there, it's assumed to be a 1. Of course, this 2 root 5 is left over, and as I mentioned, we can't add these together because they're not like terms. As a result, that's my final answer right there. There's nothing else I can really do with that. Okay? However, sometimes your radicals aren't always in simplest form. Let's look at example 3 on page 186. It looks a bit like this. So it is 2 root 27 minus 4 root 3 minus root 12. Okay? So first of all, I notice that these radicals do not have the same radicand. So what I'm going to try to do is, for now, just I'm going to forget about the coefficients. I'll deal with them later. For now, I'm going to look at the radicands here and try to see if they can turn into like terms. Well, if I look at the square root of 27, I can simplify that radical by prime factorizing it. Well, 27 can be written as 3 times 9. 3 is prime, so I stop there, and 9 is not prime, so that can be broken down into 2 more 3's. So I could say that the square root of 27 is the square root of 3 times 3 times 3. Of course, I've got a pair of 3's here now, so they would bring 1 3 out front, leaving me with 3 root 3. Okay? 4 root 3, that's simplified. I can't bring 3 down any lower. 12, I can prime factorize. So 12 would be 4 times 3. Of course, 4 can break down into 2, and then we have 3. So I can say that root 12 is square root of 2 times 2 times 3. I've got a pair of 2's underneath that brings a 2 out front, leaving me with 2 root 3. So now you might notice that this root 27 can turn into a root 3. This root 12 can turn into a root 3. Okay? So it actually appears that we will have like terms. So I'm just going to rewrite the original down again here. Now, root 27 we simplified and we said it was 3 root 3. Root 12 we simplified and said it was 2 root 3. So what I'm going to do is rewrite this root 27 as 3 root 3. 3 there. But keep in mind, this is just 1 root 27, right? I have 2 of them here. So what I'm going to need to do is multiply it by 2. All right? So of course 2 times 3 is going to give me 6, so this really gives me 6 root 3. This minus 4 root 3, there's nothing else to do here, so I just leave that as is. The root 12 can be written as 2 root 3. There's no number here to worry about. I guess it would be a 1, but multiplying by 1 doesn't change anything. So I could just write minus 2 root 3. And you can see here, these are all root 3 terms now, so I can put them together. Well, 6 root 3's take away 4 root 3's would give me 2 root 3's. And then 2 root 3's take away 2 root 3's would actually give me 0 root 3's. Of course, 0 times root 3 is equal to 0. So that would be my final answer. Okay? So the important thing to realize there is that if initially your radicals don't look like radicals, you may be able to simplify them to make them like radicals. Let's do one more example. Let's say we've got root 32 plus 3 root 8 minus root 18. Okay, so let's prime factorize to simplify the radicals. First of all, root 32. Well, 32 can be 4 times 8. 4 is 2 and 2. 8 is 2 and 4. And 4 breaks down to 2 and 2. Okay. 8 is 4 and 2, which is 2 and 2. And 18, I'll do down here, could be 3 and 6, and 6 is 2 and 3. Okay? So, if I've got root 32 plus 3 root 8 minus root 18, I know that root 32 can be written as the root of 2 times 2 times 2 times 2 times 2. I've got a pair of 2's here, that brings a 2 out front. I've got another pair of 2's here, that brings another 2 out front, leaving me with 2 times 2 root 2, which of course is 4 root 2. 3 root 8, well, looking at just the root 8 for now, root 8 can be written as 2 times 2 times 2, a pair of 2's underneath, brings a 2 out front, leaving me with 2 root 2. Root 18 can be written as the root of 2 times 3 times 3. That gives me a pair of 3's that come out front, which leaves me with 3 root 2. So I've got these 3 that are now actually like radicals. Okay? Now, I've got root 32 plus 3 root 8 minus root 18. Root 32 we just found was equal to 4 root 2. So 4 root 2. 3 root 8, well, I found that 1 root 8 was 2 root 2. Right? So root 8 is 2 root 2. And I've got to multiply it by 3 in front. 3 times 2 gives me 6, so this is 6 root 2. Okay? The root 18 is 3 root 2. So then I've got 4 root 2's plus 6 root 2's gives me 10 root 2's. Subtract 3 root 2's gives me 7 root 2's. And that's my final answer. So that's how you add and subtract radicals.